All right, let's test your primary school knowledge again. Area, which represents the space a 2D shape occupies. So 2D shape, we've got a square in this scenario here. We're looking for the space that the square occupies. What's the formula again? Can I please have, let's go with Charlie.
Width times length.
Good. So usually width times length. So two-dimensional, you've got a width by one line, and then perpendicular to that, you've got length. So usually it's width times length, but in a square specifically, these dashes mean the sides are all equal. So instead of width times length, it is length times length. Very good. And length times length, we can write that as length squared. Okay, so that's the formula to find the area of a square. Very good. Copy that down. Next one, rectangle, which actually all students know. It's length times width. So you take the longer side. If you didn't know, length is usually the longer side. Although sometimes at year 11 and 12, they don't specify that. But usually length is the longer side. Okay, width is the shorter side. So we normally say this is the width and this is the length. Area of rectangle is length times width. And then what about a parallelogram? Hands up if you know the area formula for a parallelogram. Yes, Belinda?
Base times height.
Base times height. Very good. It is this base, which is the distance from here to here, times the height, which is usually 90 degrees to it. So right here, base times height. The logic to it is if you actually cut that height, see that little triangle there? If I just cut that corner, because it's a parallelogram, they're both on the same angle. So that means if I took this triangle, it should fit over here too. So if I took this triangle off and put it over here, it ends up being length times width. That's the area of a rectangle. Okay, so for those who can't see it, I'm just going to draw it again. If you took this triangle and then you placed it over here, then that means it is now the distance from here to here is your length, and the height is actually just the width. That's why area of a rectangle is length times width, but in a parallelogram, we can then just say base times the height, and it means the same thing. So if you understand a rectangle, you understand a parallelogram. Okay? Next one, triangle formula, which most of us know, it's half of base times height, and this is your base. And your height. Notice that the height, every time we talk about height or any other length side, have you noticed that it's always 90 degrees with each other? The reason for that is because it's 2D. 2D means that it's two dimensions. So you have one dimension as a number line, and if you want to make another number line, we normally do a perpendicular line to it. That's why it's two dimensions. That's why how we find area, how much space it covers, we use 90 degrees. So most of the formulas, one of the ways to figure it out is look for the 90-degree angles, because all of them are 90. So this is 90, this is 90, this is 90 over here, this is 90 as well. They're all 90s. Okay, so it's two dimensions, 2D for two dimensions. All right, so this is 4C. Exercise 4C was just knowing the four formulas there, and you identify the shape to then work out the area. But before we do so, one other common thing that a lot of students don't know as part of a Victorian skills that you need to know is called unit conversions. Funny enough, I asked my engineering cousin once when he was at uni how to convert from, say, centimeters into cubic centimeters. He had no idea. It's just one of those things that you learn, but then you don't use often enough to understand why it works. So I'm going to show you why it works. But before we do, let's copy the conversions for area units. Notice here, a lot of students say it's kilometers squared, and then they say meters squared, and they say centimeters squared and millimeters squared. That is the wrong language. If you went to a real estate or try to buy at an auction, the real estate agents will laugh at you because it just doesn't make sense to say meters squared. The proper name for it is squared meters. So when you buy a house, listen to the auctioneers one day, or if you go and watch what your parents do when they buy it, they measure it in terms of squared meters, squared centimeters, squared millimeters. They don't say millimeters squared. They don't say, because that means something else. Okay, so when you say the language, if you mean M with a square in front of it, it's actually squared meters. I'll tell you the actual, when it comes to buildings, the language square versus squared meters. And so then you understand why we do that. But here we go. The conversion is, if you want to change from squared centimeters to squared millimeters, there's a usual concept that a lot of students mix around. It's counterintuitive. Remember, 1 centimeter, if you want to convert it to millimeters, what do you do again? Times by 10, not divide by 10. Yeah? And the logic is that there are more millimeters than there are for centimeters. So if you're going from a larger unit to a smaller unit, you've got to multiply. So all of this should be multiplied. So it's usually multiplied by 10 meters to centimeters is times by 100, and then kilometers to meters, 1,000. Very good. But that's for length units, and that's why a lot of students make a mistake. So remember I said, I asked my cousin, an engineering student, how do you convert from length units to cubic units, volume units? And this is one of the parts that they don't understand. You see, because we're dealing with area, it's not 1 dimension, it's 2 dimensions. Because it's 2 dimensions, it's not times by 1,000, it's a times by 1,000 squared. Same thing with 100, it's 100 squared and 10 squared. Fix that as part of your notes. Going backwards, it's divide by 10 squared, divide by 100 squared, and then divide by 1,000 squared. Now, why would students like an engineering student forget something like this? It's because they don't understand why. So I'm going to show you why, so you don't forget. Think about it. When you buy stuff, and most things, later on when you buy carpet or something like that, go to Bunnings. If your parents ever take you to Bunnings, they'll be in square meters. That's how they measure it. They'll say, $5 per square meter. This here, when you say 1 squared meter, what you're saying is it's 1 meter by 1 way. So 1 meter, 1 meter for 1 length, and by another meter. So if you kind of picture it, a meter is about a footstep length, like a step length. So this is about a meter, roughly. So that's 1 meter, 1 length, and if I do another 1 meter, about there. So this square that I'm sort of occupying, that's 1 square meter, if you had to picture it. So it's 1 step forward, 1 step to the right. That is the space that I occupy. That's 1 square meter. Okay? So if this is 1 meter by 1 meter, can you see why that's 1 dimension? This is 1 dimension. But if you're looking for the area, you have to convert these two as well. So if you want to convert from square meters to centimeters, yes, you were right. It's times 100. But do you notice here, 1 meter, if you times this by 100 to convert it to centimeters, that's 100 centimeters here. You times by 100 once. But then you're going to do the same thing for this one. You're going to convert this to centimeters as well. Can you see why 100 centimeters times 100 centimeters, you actually ended up timesing 100 twice. That's why it's times 100 squared. Because that's what you do. You said to find the area of a square, you told me to find this area, it would be length times width, or length times length. So it would have been 1 meter times 1 meter. But 1 meter is the same thing as saying 1 times 100 to change to centimeters, times by 1 times 100 again. This is why, when you times 100 twice, that's why the formula was 1 times 100 squared. See that? And you can use that theory for 3 dimensions. See, if I drew a 3-dimensional shape, it's the same thing. Same idea. So if you did 1 meter by 1 meter by 1 meter, so if you want to know how to change from cubic meters to cubic centimeters, it's the same idea. It's times by 100, times by 100, times by 100, so it ends up being 100 cubed. So the formula all stays the same. The only difference is that's going to be cubed. So that's what I mean by understanding the logic of it. So if you visualize what 1 square meter looks like, that's 2 dimensions. That's a space. That's where the formula or conversions work. All right? Now going back to houses. When you buy a house, anyone know the average space in a house? No, that's land, like the entire land. So yes, average land size, yeah, about 400 to 500. So land size. So land size, you're right. But I'm saying house size. So when you buy a house, it's much smaller. Anyone know the average? Oh, that's a big house. The average is 24. And if you think about it, it makes sense. Think about your room. If you had to think about your bedroom, does anyone know when you draw a house, right? And we talk about a bedroom, say your bedroom's on a corner, for example. If you had to guess the width and length of your bedroom, does anyone know what the average standard size is? Not too bad. It's 3. Think about it. 3, like your bedroom can't be 2 steps, like 1, 2. That looks very small. Most on average is about 1, 2, 3. So that's about, see that width? And then if we go 3 steps, 1, 2, 3, you can see that's about pretty good. I'm taking big steps too, by the way. That's a bedroom. Yeah? But 3 by 3, if we did a 3 by 3 here, 3 by 3, what's the area? 9. How many bedrooms on average does a house normally have? 3. 4 is a bit big. If you have 4 bedrooms, that's a pretty big house, right? But 3 times 3 gives you that 27. That's a nice, pretty decent house. That's 27 square meters already. Yeah? So if you add on the kitchen and all that, then it gets just a bit bigger. But on average, because we're taking the average, means there's houses that are units, houses that are apartments. So on average, it's 24. But a house average, something like this standard, you can expect about 24 to 30. That makes sense. Can you see how I'm calculating it to become about 24 to the 30 mark? And that's how you can kind of figure it out. So number of steps you take, that gives you roughly estimate of meters in a room. Yeah. So you can kind of guess the average area of this room by guessing how many steps it takes to go to one side to the other side. You can kind of average the space. So any room that is at least more than 3, so it's about 4 and 5, whoa, that's a huge room. So your parents' room, like a master's bedroom, for example, it's probably about 4 to 5. It's a pretty huge one, yeah? But why am I talking about that? Oh, sorry. Let me fix that. What did I say? 24, is it 24 squares or 24 square meters? Oh, sorry, I got myself confused. Not 24 square meters, sorry. The average house size is 24 squares. Yes, that makes a bit more sense now. Now, notice why I said the language was important. When you're selling a house, they talk about squares and then they talk about square meters. So when they talk about land size, they do say like what Garissa said before, it's about 400 to 500 square meters, okay? But when they sell houses, they then talk about squares. And this is where it's different. That's why when people say meters squared, it sounds funny because are they talking about this one or are they talking about that one? 1 square, when the real estate agents tell you, they say, oh, this house has 9 squares or whatever it is. 1 square is equivalent to 9 square meters. And the 9 square meters is equivalent to a 3 by 3 room. Okay? So when they talk about squares, that's what they mean. So when you hear the real estate agents, they say this is 9 squares or 10 squares, what they're really saying is you got to times by 9. So whatever that number is they say to you, if they say it's 9 squares, you times by 9, and that gives you an idea of how many rooms you can fit the standard room into that house. Does that make sense? Okay? So the language when you're reading this, I am going to catch you out when I ask you a question. If you say meters squared, I'm going to fix you. You must say it's squared meters squared, centimeters squared millimeters, not the other way around. Same thing with cubics. You say cubic meters, cubic centimeters, cubic millimeters, not the other way around. Yeah? And another one that you might see if you ever buy a house, or actually you're very unlikely to see unless you're very rich. HA, what does that mean? Hectares. Actually, I wrote it there. Hectares to square meters. Anyone know what 1 hectare is in terms of square meters? Ooh, just a few more zeros. One more? 10,000. 10,000. Now, sounds big, but if we had to visualize what 1 hectare looks like, to get 10,000 as an area, that's 4 zeros. So that means you need 2 zeros for the first one and then 2 zeros for the other length. So you would need 100 meters by 100 meters. Now, if you think about your racetrack, you know, when you do the 100-meter sprint, think about doing a 100-meter sprint one way and then a 100-meter sprint the other way. That square, that entire area is equivalent to 1 hectare. And that's why most farms, and you know, if you look at the Lower Plenty area, that big space that they have, That makes sense. It's about a hectare or 1 point something hectare. Okay? But you're really just talking about 100 meters one way and 100 meters another way. Cool? So visualize that. So that's how you picture a room, and you can picture a hectare. Very good. On to the next one. So you got some formulas, and I tried to explain in theory what the unit conversions mean so that you understand what those units mean. Let's do some examples. Here we go. Example 1. Flip over the page. All right, here we go. 3.51 squared meters, not meters squared. Squared meters to squared centimeters. So first thing in your head is you think, how do I convert from meters to centimeters? You times 100. There's 100 centimeters in 1 meter, so you times by 100. But because this is area units, notice it's squared, then you need to times this to convert it. You got to times by 100 squared. For this chapter 4, you can use a calculator. Okay, we don't expect you to do it by hand, so you should be bringing your calculator to these classes. So here we go. Let's do it on a calculator. This is my Year 9 accelerated. I'll now change. Let's do that one. Okay, so 3.51 times 100 squared. Now 100 squared means 100 times 100 times itself. Okay, so if you don't know how to do the square button, you can do times 100 times 100. Or if you didn't know how to do a square button, on this calculator is the little hat. See that symbol there? Yeah, that symbol means power of. So it looks like this on a spreadsheet. It looks like this. So that symbol there on your calculator, the little pointy arrow, that means power. Okay, so if you type 3.51, do the little hat, because my one doesn't show it. It comes up as a little position, and you do, times 100 to the power of 2. Same thing. Okay, so you can either split it up. 100 squared means 100 times 100. Type in your calculator, 3.51 times 100 times 100. So the answer is, you have now 35100 squared centimeters. Okay, so that's the conversion. Next one, same thing with squared millimeters. How do you convert from squared millimeters to centimeters? So millimeters to centimeters, no, not times. Divide, because it's smaller. So millimeters is smaller than centimeters, so you divide. It's counterintuitive. So you divide by 10 usually, but because it's area, so 10 squared. Okay, so 150. Here we go. We do 150 divide. So here's my divide symbol. 10 squared. And I get 1.5. Okay, if you don't know how to do it again, you can do 150 divided by 100 divided by 100. Okay, so if you type 150 divide 100, you should get the same, I should have put brackets in. So it should have been 150 divide 100 and then divide 100. Oh, what's going on here? 150 divided by 100. Is it 150? Oh, sorry, it's not 100, it's 10. Oops. Divide 10. Divide 10. There we go. 1.5. All right, so 10 squared. Again, if you don't know how to do the 10 squared in your calculator, you can just do divide 10, or you can do divide 10 squared. Both the answers are the same. Okay? So that should give you 1.5. That's unit conversions. That's part of the exercise to practice how to convert. You just use the chart and follow the chart that I gave to you over here. Follow the chart. Follow the arrows. All right. First one is pretty easy. What type of shape do I have for A? Can I please have, let's go Ryan. What shape? Rectangle. Area of a rectangle is what? Let's go Jacob. Length times width. Very good. In this case, what is my length? Let's go with Ollie. 7. Very good. 7 centimeters times width is the shorter side, so 3 centimeters. 7 times 3 is equal to what? Let's go with Belinda. 21. Good, but don't leave your answers like this. You must have the units, otherwise I'm going to penalize you. Good. Don't say centimeters squared. It's squared centimeters. Very good. Make sure to put the units, otherwise I'm going to penalize you. Next one. What shape is this one? Let's go with you, Chen. What's B? What shape is this? You don't know? Starts with P.
Parallelogram.
Good. Parallel, so spell as parallel and then ogram. Okay, parallelogram. And then same thing, base times height is the formula. Here we go. What's my base in this case? Let's go with Fitzroy.
10.
Good. 10 meters times my height would then be 4 meters. And 10 times 4 is what, Hamza? 40. But we don't leave it as 40. We say what, Adele? Close. Squared meters. Very good. But at least you said squared. You said squared. Very good. So 40 squared meters is the correct answer. Next one. What shape is C? Can I please have Zara Jones? Triangle. And we got half times base times height is the formula. So we go. Aqualia. What is my base? Good. 8 meters. 8 meters is my base. So here's my base. Times the height, which is 5. So we go, half of 8 is 4, and 4 times 5, which is 20, and we write our answers as 20 squared meters. Very good. Don't say meter squared. That's what most students would say, and most people would say. Sounds funny if you're at an auction. All right, next one, D, total area. Now, this case, this is a funny shape. It's not one of the 4 shapes I had shown you, but you can use your knowledge of the 4 shapes to find the area of this composite shape. Composite just means like a group of different shapes put together. Okay, so that's the shape I want. But you see, I can find that area by finding the full area first. If I found this full area, that is a rectangle. But then if I subtract this area, if I just take that one off, if I just cut that area off, I'll get the yellow area that I want. Does that make sense? So if I just find the area of the full entire region, and then I minus the area I don't want. See, that's a triangle there. So you now need to figure out what is the area of a rectangle. So I'm going to color it in blue. Area of a rectangle, it's length times width. So we've got 10 times 8 will give you the area of a rectangle. So it's 80. But if you minus then the triangle, which is in red, so the triangle, I don't want this area here. If you just subtract that area off, if you cut it off, then you get the leftover that you want, right? So then that's how you get the yellow region. This is what I want. Area of a triangle, you already know the formula is minus half times base times height. My base and height, what is my base in this case? Let's go with Charlie. What's the base? 10, very good. It actually doesn't matter as long as you find the two 90-degree perpendicular lengths or dimensions. So you've got 3 and 10. I like to choose 10 because it's the longer side, so I'll call it 10. And then base can be, the height can be 3. Okay, you can rotate this triangle if you want. If you rotate it like this, that might help you to think this is 3 and this is 10. How do we know it's 10? If this side is 10, this side must be 10. Okay, so it's just a bit of problem-solving analysis. That's what this whole chapter is about. So let's put it together. We get minus half of 10 is 5. 5 times 3 is 15. So really it's 80 minus 15. And 80 minus 15 gives you 65. Don't leave your answer 65. It should be squared meters. Very good. So far, so good? That's 4C. Pretty easy. Yeah, so I only taught you how some of the formulas for the basic shapes and then some unit conversions. I try to give you a bit more understanding of unit conversions. Flip over the page. We're on 4D and you're just going to memorize another 2 types of shapes. Here we go. Flip over. Hey, where'd it go? Oh, do you have to draw them, do you? 4D. No, you don't have to draw them. It's here. Oh, of course you do. You got to practice. You got to practice mainly notation. Don't worry about the look of the shape as long as your notation is correct. All right. You got 3 shapes to add on to your list of basic shapes. Here are your 3 basic ones. A kite. Some of you call it a diamond. How do you know if it's a diamond? Very easy. Notice that the opposite sides don't equal. See, a rectangle, opposite sides equal. A square, opposite sides equal. Parallelograms, opposite sides equal. A kite, one of the first things that hints it out is the opposite sides do not equal. Okay? So notice that this side and this side, they're opposites, but they don't equal. That's usually a hint. And then the other thing is that you can find a spot where you can cut it in half. You should get two triangles. Okay, that's when you know you've got a kite or a diamond. A lot of students confuse between a kite and a rhombus, especially if they're not looking at the notations. The notation's the hint for you to know which shape you got. Now, a rhombus, see, it kind of looks like a diamond as well, especially if I don't put any symbols on it. See, if I wanted to make this a kite, all I had to do was do this, and then opposite sides are not equal. That technically is a kite. But in a rhombus is like a square, but tilted. And one of the properties of a square is that all sides are the same. So can you write that down? All sides are the same. Put in the symbols. Rhombus, all sides with a dash to show that all sides are the same. So that's the difference between a kite and a rhombus. Don't rely on your intuition on the shape, but rely on the notation. Because in your textbook, some of them will draw it to look like a rhombus, but they use the symbols to tell you it's like millimeters off, and technically it's a kite. Okay? So you have to use the symbols, not the shape that you think it should be. All right? All right, so the formula for a kite is half times diagonal 1 times diagonal 2, and so it's just one corner to the other. That's one diagonal, so diagonal 1. The other corner to the other corner is diagonal 2. Times those two together and then halve it. That will give you, well, in this case, it was x times y. Okay, because x is this height, so from this point to this point, that's x, and then y is from this point to this point. So we say half times x times y, or if, to help you remember, it's half of the diagonal 1 times diagonal 2. Very similarly, rhombus is actually the same, and a lot of theory is the fact that you can split up into two triangles, so it actually ends up being the same thing again. It's half of diagonal 1 times diagonal 2, so this one times this one. So D1, diagonal 1 times diagonal 2 will give you the same formula. Okay, so formula for a kite and rhombus are the same, but different to a parallelogram. Okay, this is because diagonals in rhombus intersect at 90 degrees. Did I spell it wrong? Pretty sure it's parallel and then ogram. Oh. Parallel and then ogram. All right, so one of the key things why this formula works and why it's different to a parallelogram, even though a parallelogram is slightly tilted as well, it's the fact that the diagonals intersect at 90 degrees. You don't need to know more than that. The proof to why the formulas work is because it's 90 degrees. It needs to be. Okay? And that's what this line is. That's only for those who are doing reasoning questions and enrichment questions. Some of it may rely on the fact that you know the intersection of the diagonals have to be 90 degrees. But if not, all you need to know is the formulas. Okay? And your last one. A lot of students forget how to tell if it's a trapezium or not. Anyone know what makes a trapezium unique compared to all the other four-sided shapes that you know? Like a kite, rhombus, parallelogram. Yes, Carissa?
I know it's like two triangles and I don't know.
That is true, but there is one more key thing. Someone just murmured it out just now. Well, you could though. You could actually have this one. Oh, sorry. Let me draw it again. You can actually have this one, these two sides, and then like that. That's also still a trapezium. So still one property that makes it a trapezium. It has to have, Carissa? Very good. One of the key things is there's only one set. You see, if you think about a parallelogram, it's got two sets. Whoops. It's got two sets. So when you draw a parallelogram, they have two parallel lines, two pairs. A square is also two. Two things that are two parallel. Trapezium is the only four-sided shape where there's only one pair. So there's only one pair. So as long as you can draw one pair, then it's a trapezium. So you can draw a trapezium many ways. You can draw a trapezium like this. These two are parallel. You can draw it like this and then make that a bit longer. That's a trapezium. You can draw another two parallel lines and then draw this one 90 degrees and 90 degrees and this a bit longer. You can draw out the one I kind of just did, so slightly shorter and then slightly longer. As long as there's only one pair of parallel lines, that's what makes trapezium a trapezium. Okay? And that helps you remember the formula as well. So I actually had my year 11s just ask me just last session, what's the formula for a trapezium? And they forgot because they obviously have memorized it but not understood where it came from. The two parallel lines is your A and B. Okay, so A plus B is referring to the two parallel lines. So A and B are parallel. Sum them together and you times by the 90 degrees. So notice again, it's always two dimensions. Area has to be 90 degrees with each other. Times by the height. So half times A plus B times height is the shortcut to finding the area of a trapezium. The long way to do it is if you actually cut it into triangle and a rectangle, or two triangles, triangle, triangle, and a rectangle. That's a longer way of doing it. Okay, but you can get the formula, which is this one. It'll be much quicker to do. Okay. All right, so A and B are the pair of parallel lines. And that pretty much concludes the formulas that you need to know. So make sure you add this to your repertoire. You have your 4 basic shapes plus these 3 special shapes. And those are the formulas you need to know for 4C and 4D. Everything else is the same. Okay, so if you flip over, there's some questions for you to practice. Otherwise, you can go on to the exercise itself. You should have about 20 or so minutes, but I'm just going to zoom in and leave this here. But that's it for today's lesson. Hope you learned something, especially squares and squared meters.